Deno is an all-in-one, zero-config toolchain for writing JavaScript and TypeScript with native support for web platform APIs. These features, combined with Node and NPM compatibility, provide excellent tools that you can use to build scalable backend services. What's more exciting is that the developer experience is further improved thanks to modern tools like TRPC, which enable you to build fully typesafe APIs without schema declarations or code generation. Building with TRPC and Deno is easier than you might think. Let's first make sure the needed dependencies are installed. Thanks to Deno's NPM compatibility, we can use the NPM versions of TRPC packages along with ZOD for input validation. This installs the most recent TRPC server and client packages, ZOD for runtime type validation, and the Deno standard libraries path utility. This is what will allow us to build a type-safe API layer between our client and server code. The first step in building our TRPC application is setting up the server. In the trpc.ts file, we'll start by initializing TRPC and creating our base router and procedure builders. This will be the foundation for defining our API endpoints. Note that the public procedure allows us to create endpoints that don't require authentication. Then, in the database.ts file, we'll create a simple data layer to manage our dinosaur data. For demo purposes, we'll create a simple file-based database that reads and writes dinosaur data to a JSON file. Of course, in a production environment, you typically use a proper database and an ORM like Drizzle or Prisma. Finally, we'll provide some demo dinosaur data in a data.json file. Now, we can create our main server file that defines our TRPC router and procedures. The code should be pretty self-explanatory. We are setting up 3 main endpoints, allowing us to return all dinosaurs, return a specific dinosaur by name, or create a new entry in the database. Inside these handlers, we'll simply call the database service methods we defined earlier. While you can run the server now, you won't be able to access any of the routes and have it return data. So let's fix that. In a clientindex.ts file, we'll start by initializing our TRPC client, and then we'll consume the data provided by the server. This client code demonstrates several key features of TRPC. First, we can automatically infer the response types based on the server router. The client automatically inherits all type definitions from the server through the app router type import. This means you get complete type support and compile time type checking for all your API calls. If you modify a procedure on the server, TypeScript will immediately flag any incompatible client usage. Second, the example demonstrates 2 types of API calls: queries used for fetching data without side effects, and mutations used for operations that modify server-side state. The client automatically knows the input and output types for each procedure, providing type safety throughout the entire request cycle. Finally, the examples.iterable demonstrates TRPC's support for streaming data using async iterables. This feature is particularly useful for real-time updates or processing large datasets in chunks. Now, let's start our server to see it in action. In our deno.json config file, let's create new property tasks with the following commands. Then, when running the Deno start task, we should see the expected output. Now that you have a basic understanding of how to use TRPC with Deno, you could use this knowledge to build and expand on top of other topics and tutorials from our channel. Until next time, thank you for watching.